Now that we are done with the four preliminary topics of a model-based documentation, we come towards agent-oriented modeling. So what exactly is agent-oriented modeling? So a few concepts and definitions first. So we talked about goals a little bit before, but specifically when we talk about agent-oriented modeling, we are following the Sterling and Tabata approach of defining what goals are and what agents are and so on. So all the definitions that you see here are based on the definitions given by these authors. You can find a reference to this in our references. So a goal is a situation description that refers to the intended state of the environment. And these states can either be functional or non-functional or quality goals. And they can also have sub-goals. So these are kind of similar to requirements, but there's a very good distinction which we will talk about later. Goals are expressed using nouns, verbs, and optionally adjectives. And nouns tend to be more of a state, the verbs more to be the activity being used in the scenario that are used to achieve a goal. For example, if a message needs to be transmitted securely, the functional goal of transmitting the message is associated with the quality goal or the non-functional goal of securely. So your message needs to be transmitted securely. Most, if not all, processes in most software systems are elicited by agents that play a certain role in your system to achieve some goal, which is why we call this agent-oriented modeling. AOM, or agent-oriented modeling, is a tool for modeling system where there are multiple agents, both human and man-made, and the various interactions between these with a diverse collection of both hardware and software in many complex environments. And this is why agent-oriented models are very clear and easily understandable for stakeholders, which is very, very good for requirements engineering because you need active involvement of stakeholders for this. So we mentioned before that there's a similarity between goals and requirements, especially between the sub-goals and having functional, non-functional, but there are some key differences. So goals are generally a single desired result of your system, whereas a requirement is a statement of need. So what your system needs to satisfy the goals. A goal may consist of several requirements, but a requirement may be related to various other goals. So you cannot always have a one-to-one mapping between goals and requirements in a general scenario. It is sometimes possible to have a one-to-one mapping within specific goals and requirements, but in general, you cannot equate the concepts of goals and requirements. So we already defined functional and non-functional requirements in the very preliminaries of this lecture series. And now we're going to go about a little bit about functional and non-functional goals. Functional goals usually describe what a system must accomplish. So essentially, it depends heavily on the system itself. Non-functional goals describe how the system must accomplish these in terms of the standards and quality. And identification of non-functional goals can depend on exactly which functional goals they are related to. However, there are many common non-functional goals that you can find, like reliability, availability, security, and so on. You can find a full list of various common non-functional goals as a reference in our slides. So what exactly is a role? Moving on from goals. So a role is some capacity or position that facilitates a system to achieve its goals. So roles express functions, expectations, or obligations of the agents and the agents that are acting inside of your system. Basically, a role could be something like a network administrator or a firewall. So it doesn't specifically say which specific agent it is. So different agents can have different roles at different times, but roles can be can be satisfied by different agents. So there isn't a one-to-one mapping between roles and agents always. So an agent can be either an entity that is human or software that acts inside of an environment. So for example, a software entity like some program like Nginx could be your firewall, or a person who is managing your whole network infrastructure could be your network administrator, playing these specific roles inside of your system. Activities, on the other hand, are some action performed by these agents playing a role in the pursuance of the system goals. And the environment is basically the abstraction or the surrounding conditions in which your agents exist and mediates both the interactions among the agents that allows them to access various resources. So inside of your environment, you're going to have different resources that are available to your system, and handling the various dependencies between these resources and making sure that there are no race conditions is something that your environment can handle. So now that we know a little bit about agent-oriented modeling, we're going to talk about two very specific selected models inside of the models that Sterling and Tevita talk about. These are goal models and behavioral interface models. So not to confuse between goal models that we talked about in a more general sense in this lecture. These are more specifically agent-oriented goal modeling. So in general, the symbols of goal modeling are kind of similar to before. So because these are hierarchical models, they express the relationships between the goals, either functional or non-functional, and the roles played by various agents in the pursuit of these goals. And we mentioned before about this and/or decomposition of goals, and generally Sterling and Taviter tend to omit this distinction between the different types of goal relations. But I think, in my personal opinion, that this is okay to have within a goal diagram. So on the right, you have this table for the different symbols used in goal diagrams. So a trapezoid is usually the symbol that's used to have the goal written inside of it. These are usually your functional goals. And having a cloud is basically something in which you can have your quality goals defined inside. Actors, just like other use case diagrams, or roles in this case, are just having your stick figures. And the relationship between your different goals and your roles is based on a solid line, and relationships between goals and quality goals is depicted using a dashed or dotted line. Here we have an example of a goal model. So this is kind of a departure from our previous example of a navigation system. Now we consider the example of an automated EV charging station. So you could theorize that the main goal of an EV charging station, an automated EV charging station, is to manage this automatic charging station. So very easy from just a definition. And we would like this to happen with some amount of reliability and availability. So as you can see, these are two top level non-functional goals associated with this main functional goal. And now you have these two sub-goals of this main goal, which is to manage charging and to buy energy. So we are trying to have a distinction between handling the different roles of these two sort of distinct parts of the system. So on the left side, you have the goal for managed charging, which essentially involves the charging port, which is the actual physical port that is used for plugging in the EVs. Within this scenario, you have also a driver that is involved for reserving the charging port and also charging the EV itself. And when it comes to charging the EV, you also have the actual EV playing a role inside the actual charging process. The charging process itself can involve something like agreeing on the charging speed. So you might notice that the charging port is not included as a role inside the charging EV part of the goal, but it's important to note that when a goal has a role associated on a top level, and if that goal is inherited, by a sub-goal, then the role is also included into the sub-goal. So the charging port, the driver, and the EV are all roles associated with the charge EV goal. But on the other hand, only the charging port and the driver are associated as roles for the reserve charging port part of this goal model. So similarly, you can have another part of this diagram that has on the right side the whole process with buying energy that for the charging. So depending on the scenario, either you buy a specific amount of energy in kilowatt hours before you start charging, or based on how much you've charged, there's a certain amount of calculation that happens on the fly. And this can include an energy provider, so the person who's providing information to the charging port, which can either be, in some theoretical scenarios, a solar power station, a wind power station, or it could be traditional gas power stations. And also you could have a payment entity, so something that processes all the payment information. So these can be separate roles that are played by different actors. Now that we have a nice example with a goal model in the agent-oriented modeling concept, we talk about the second type of agent-oriented model, which are termed as behavioral interface models. So far, we have only talked about the goals of the system, but this aspect that we talked about before, the behavioral perspective, has not been captured by this goal model. And this is something that behavioral interface models address. How do they do this? So essentially, they model behavioral units which are equivalent towards activities. And these are generally represented as a table shown in this slide here. So you have the activity, you have the triggers for this activity, and you have some preconditions and post-conditions. So essentially a precondition, similar before, is like conditions that are required for an activity to proceed, and conditions that are required to be fulfilled to consider the activity to be completed. Considering the example of the automated EV charging station, we are going to have a BIM, or a behavioral interface model, of the sub part of the system that is more to do with managed charging. So one of the first activities that you can consider is reserve charging port. You might notice that the activities on the left-hand side are derivations of the functional goals in your goal model. This is very important, and this is an important method of derivation of the behavioral interface models. Generally, what you do is you derive your goal model and behavioral interface model in conjunction, or one after the other. There is always a feedback loop between this process. So when you reserve charging port, a trigger for that could be that your driver wants to charge the EV. So a precondition for having a charging port reserved is that a driver has already bought a certain amount of energy, and the charging port, or CP, is already free. And another precondition could be that the EV is ready to charge. Essentially, if an EV cannot charge, or it's already full of charge, then the part of reserving the charging port would not really continue. And once this activity is triggered, we have the condition of the driver is basically reserved the charging port. Once this happens, you have the charge EV activity, and you can see that the precondition for this activity is the previous activity. So the driver has already reserved the charging port, and once that happens, once the driver has charged the EV, the state of the system turns into the driver has charged the EV. And you can see a similar theme happening in the subsequent activities. So agreeing on the charging speed has some preconditions, such as a reserved charging port, and also some extra information here that you don't see in the goal diagram. For example, if the maximum speed of charging of the charging port is too high in consideration towards the EV, then you cannot charge with the speed of the charging port. You need to consider the maximum speed of the EV. So for example, you don't blow up your EV by putting too much power into your charging port. So these kind of conditions need to be considered before charging, for example. So very similarly, you can begin charging once you agree on a charging speed, and once the EV has completed charging, you're done with charging. So it's nice and simple. It shows you what happens before and after an activity and how these activities relate with each other. So to summarize model-based requirements documentation, we talked about conceptual models as a means for requirements documentation. Essentially, you need to focus on more about having a good abstraction and a good overview of your models rather than going to complete detail of a very specific modeling language. It's very good practice to have a wide variety of models for modeling different purposes or perspectives of your data. Every model can fit a different purpose or aspect of your system. As an example, UML can provide a large variety of different models that we have looked at examples for to model pretty much anything. And we only covered a small part of UML. There are many, many other types of UML models that can be useful for requirements documentation that we haven't covered here. And furthermore, UML is not the only answer. You don't have to always stick to UML to model your requirements documentation. Other models are also okay. As a self-study for you, we also have some examples for UML use case specification templates, which we haven't described during the lecture as examples. These can also be relevant for the examination. After we talked about UML, we went into a very specific type of modeling called agent-oriented modeling, which is specifically from the Sterling and Taviter approach. We talked about the differences between goals and requirements within this context. And then we elucidated a little bit about goal models and behavioral interface models within the example of having an automated EV charging station.